Hi everybody, welcome to today's lecture on working with proportions. This is one of the most fundamental and versatile topics in SAT math, so mastering it will help not only on test day, but in many real-world applications as well. By the end of this lesson, you'll feel confident in solving proportion problems, solving proportion problems and scaling relationships, including square and cubic relationships. So, what are proportions, right? So a proportion is an equation that states two ratios are equal. For example, A over B equals C over D. Here, A, B, C, and D represent numbers or quantities, right? And the way you solve proportion equations is that you can cross multiply to rewrite this equation as A times D equals B times C. Okay? And one key point to remember, proportions are especially useful when solving problems involving scaling, unit conversions, and relationships between quantities. What do I mean by that? Well, let's say, you know that 12 inches equals 1 foot, right? So we know that there's 12 inches in 1 foot. Say we want to find out how many feet 36 inches contain, right? And if we were to cross multiply, we'd figure out, and if we were to solve for this value right here, we'd figure out that in 36 inches, there's 3 feet, okay? So that's one real world application. Okay, so let's solve a simple example. If 4 apples cost $2, how much would 10 apples cost? Okay, so for this question, we'll set a proportion. 4 apples cost $2, right? And we need to find the cost for 10 apples, okay? And if we cross multiply, we'll get 4x equals 20. And if we solve for x, we should get 5, okay? So that's another example of how 10 apples would cost $5. And how do we solve this? We just set up a proportion, okay? And remember how when we set up a proportion, notice how in the numerator we have corresponding types of elements. So in the numerator here, we have 4 apples and 10 apples. And on the denominator, we have the cost. Okay, so that's very important to keep in mind to make sure that your proportion equation has all corresponding parts that are aligned with it, whether it's on numerator or denominator. Okay? Now, let's talk about scaling in proportions. Specifically, square cubic relationships. Okay, so the first one we'll consider is linear scaling. Linear scaling means quantities grow or shrink proportionally. If you double one side of a rectangle, right, So if you double, let me write this down. If you double rectangle side, new side is 2 times x. Okay, so the change will be proportional. Okay, so what does that mean? Let's say if you have something that, let's say, or triple it, the new side is going to be 3 times the original length. That makes sense? So if, let's say, the side length we have of a rectangle, it was 4, we triple it, the new side is going to be 12. Okay? Now, when working with square relationships, now we're introducing a square element. So let's write this down. Square relationships. And what this means is that when you're working with areas, right, the key point to remember is that area scales with square of scaling factor. Okay? So what does this mean? So if you shape, or if you scale a shape by factor of k, the new area is just going to be, let's write the formula here, new area equals old area times k squared. So what exactly does that mean? Well, let's consider some examples. So let's say a square has a side length of 3, okay? So its area, 3 squared, is going to be 9, right? So now let's say that same square, we double the side length to 6. So what is its area going to be? Well, the new area is just going to be 6 squared, which is 36, right? Notice we doubled the side length over here, but notice the difference between the areas. 36 is 4 times 9. So the side length doubled, but the area increased by 4 times. That's because our scale factor was what? 2 in this case. And remember, the new area is just going to be the old area times the scale factor squared. And what's the scale factor squared going to be? Well, that's just going to be 4. That's why this new area over here is 4 times the old one. Okay? Now, let's consider cubic relationships. Okay? And if you scale an object by a factor of k, the new volume is going to follow this formula. new volume equals old volume times the scale factor cubed. Okay, so what does this mean? So let's say, for example, you have a cube, okay? And it has a side length of 2. So what is its volume going to be? Well, the volume of a cubed is just 2 cubed, which in this case is just going to be 8. So if the side length triples to 6, let's say instead of 2, we have a little bigger cube. The side length triples to 6, right? Notice how this is a threefold increase. So 2 times 3 is going to be 6. What's the new volume going to be? Well, 6 times 6 times 6, 6 cubed, is just going to give you 216. Now, when we consider the volumes 216 and 8, you'll notice if you were to really take 216 and divide it by 8, that 216 is 27 times 8. And why is that the case? Because our scale factor is what in this case? Well, our original scale factor is just going to be times 3, right? Because we go from a side length of 2 to a side length of 6, which is a 3 times increase, right? And what does this rule say when you're scaling by a factor, when you're dealing with volume, is that your old volume is going to be multiplied by your scale factor to the power of 3. And if we take 3 and cube it, what do we get? 27. Okay? And if we were to consider the new volume, right, which is 216, and let's consider this formula, the old volume, which is 8, and let's say this is k cubed, and we're just trying to solve for k, right? Divide both sides by 8, you'll get 27 equals k cubed. And if you were to solve for the scale factor, k, well, what's the cube root of 27? Well, you're just going to get 3, which is consistent with the situation. Okay? So that's a little nuance you have to keep in mind when you're dealing with square relationships and volume relationships. Okay, y'all, so we covered the basics of proportions and how to scale with linear, square, and cubic relationships. Okay? See y'all in the next lecture.